In this video, I want to talk a little bit about the cost matrix for the German credit dataset and how to interpret it. So here's the table that's given to you on the Dataset website, and here is the description. So what's the description say? The description says that it's worth to class a customer as good when they're bad, and that costs 5, than to class them as bad when they're good, that costs 1. So how do you interpret this table in this context? So this 5 is here, and this 5 corresponds, it says, to classing the customer as good when they're bad. So good means 1, so this means that this is the prediction. And this is the true class. Right? So if the true class is bad and the prediction is good, is 1, then the cost is 5. If the true class is good and the prediction is bad, that costs us 1. If the true class is good and the prediction is good, that costs us 0. And finally, if the true class is bad and also the prediction is bad, that also costs us 0. So this is how you figure it out. You say, okay, so good when they're bad is 5. That means that it must be the case that this is the prediction and this is the true class. So, okay, that's the cost matrix. Now let's look at some fake data and see how we compute the cost. So here I have 5 rows, and for each row we have the actual class of the customer. So this is bad, 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 good, good. So this is the actual class. Now this is pi I, so this is the probability that our classifier, our model, outputs. And it outputs as a probability, so if it outputs the logic, we then transform it to get the probability. And here we got to decide what this means, and depending on how you fit the model, it'll be different. So here I said, okay, so the pi I is the probability that the customer is bad. To be clear, this pi I, this is what you get when you take the logistic function of the log odds. You get this. So from the model. So okay, how do you classify it? Well, if the probability that the customer is bad is 0.3, that means that here you'll say that the class is good. Here it's bad, and the probability that they're bad is 0.6, which means that the class is bad. So the way you determine the class that the model predicts is by looking at the probability and saying if it's greater than 0.5, then it's bad. If it's smaller than 0.5, then it's good. And whether larger than 0.5 means bad or good, well, that depends on how you fit the model, which one of good or bad you set to be 1 and which 0. So, okay, this is going to be bad. This is going to be good. And this is going to be bad. So what's the cost here? So the actual class here is bad, but the prediction is good. So predicting good when the customer is bad, that costs us 5. Predicting bad when the customer is bad, that costs us nothing. That's a 0. This is a 0 as well. Predict good when the actual customer is good, that costs 0. Predicting bad when the customer is good, that costs us 1. So that means that for this data set, the total cost is 6, and the average cost is 6 divided by 5, so 1.2. Because the total cost is 6, and you have 5 data points, so the average cost is 1.2. Okay, so how to figure this out? Well, here's one way that you can go about it. You can say, okay, so we'll take 5 and we'll multiply it by the number of times we classified bad as good. And then you add to it 1 times the number of times we classified good as bad. So that's the same thing as what we did here in order to compute the total. The only thing that's different is here we just count the number of times when we had this kind of thing, and we count the number of times where we had this kind of thing. So what would it be in this case? Well, it would be 5 times 1. Why 1? Because we only had this kind of case where a bad customer got classified as good the once. And we have 1 times 1 as well because we only have one line like that where a good customer got classified as bad. That cost us 1, and this is 6. And this is the total cost. If you want the average cost, you of course just divide by the number of rows. How to compute this guy? Well, see a previous video where we computed the number of false positives and false negatives.